So we've looked at units and we've looked at converting units. And so one thing that we are going to look at in this first groups of sessions, is density. Density is what we call a derived unit. And that means that it's more than one type of unit together in a measurement. And so by definition, density is a physical property, and it is basically the bridge between mass and volume. So it tells us how much a certain volume will weigh. If you remember, we kind of use those interchangeably. So density is equal to the mass of the material divided by the volume of that material. Okay, and so you use this as a great conversion factor, because if you have volume and you want mass, you can use its density in grams per milliliter to do that conversion. If you have the volume and you want to go, you have the mass and you want to go to volume, then you just use that conversion factor flipped upside down, just like we know we can do, and that'll give you milliliters. And so we use this a lot in chemistry because sometimes we're given a volume and what we really want is the mass. So here's an example of the problem. If the density of acetic acid is 1.05 grams per milliliter, what is the volume of 5 grams of acetic acid? All right, so when we take inventory, we're given 5 grams, and we want to know how many milliliters that is. All right, so we use density as the conversion factor because we can write it either 1.05 grams per milliliter or 1 milliliter over 1.05 grams. And so we've just got to choose which way to start it. If we remember, if you are starting with grams, you're going to want what? Grams on the bottom so that it can cancel that unit. And you're looking for milliliters, so density is what you'll use because you'll end up with milliliters. So you start with your 5 grams, so you start with what you're given. You multiply that by the density, making sure that you have grams on the bottom, so it will cancel out. And then, so that's 5 times 1, and then divided by 1.05, and that gives you 4.761904, whatever, in your calculator. We're going to look back. We had 2 significant figures to begin with, so we're going to round that to 4.8 with 2 significant figures as our answer. Specific gravity is a term you're going to hear as well. Specific gravity actually has no units because it is the density of the substance you're looking at compared to the density of water. And the density of water is 1. Okay, density of water is 1.00 grams per milliliter. And so when you have the density, say it was the 1.05 like we saw in the other problem, divided by 1 gram per milliliter, okay, it's 1.05, which means basically the density and the specific gravity are the same. They just don't have units when you're talking about specific gravity, because your grams over milliliters and grams over milliliters cancel.